Hello, everybody. All right, so today we are looking at section number 16. All right, so section number 16 is on pages 207. Okay, so this section, probability, will be broken into 3 separate videos. So the first video will cover pages 207 to 209. The second will cover pages 210 to 215. And the final one, which is the third video, will cover from pages 216 to 224. Okay? And that will bring us to the end of section number 16 under probabilities. Is that okay? Nice. So let me give you an introduction. And we actually have discussed probability in a little sense, right? When we're looking at section 15, where we had to use the z-score tables. So that actually gave us a peek into the discussion about probabilities. So here we're going to have a full-blown conversation about probabilities under this section. All right, so we have already started a discussion about probability in the previous activity. So let's get more specific. Now, in this activity, we learned the rules of probabilities and how to calculate probabilities using tabulated data, right? More specifically, we discussed the subtle nuances of the words and, or, not, given, and if in association with probabilities. So these shall be our learning objectives, and let's get the conversation going. Are you ready to go? All right. So we are going to define probability, but this is where we start from. So thus far, you've worked with data sets that have already been summarized. So here we are going to look at a raw data set, and this data set talks about minutes customers have to wait for service. Now, the whole concept of probability started as a game in France by 2 mathematicians, all right? And now this concept spans across a wide range of areas. So if you talk about insurance, if you talk about almost everything, is probabilities, right? So it has a lot of detailed applications, and we are going to really get into it. Now, so we have this raw data that talks about the minutes customers have to wait. Is that okay? So we have to now take this raw data and then convert it into a simplified or a summarized data set. Now, we have to use a frequency table to organize the data by counting, right? Now, counts can be used to create bar graphs and histograms. Now, for this data, you should also find the proportion of customers in each category. In this context, proportion refers to the fraction or percentage of customers in each category compared to the whole. Note there are several ways to express this. So we are going to organize this data, right? It doesn't look as organized. So we are going to organize it. So we're going to put it on a frequency distribution table, and that's what you see here. So we look at, we put it on the table. So minutes customers waited, and then the frequency. So the frequency refers to the number of times, and then we look at the proportion. So we take the number 1 and you cross out. So 1 shows up once, so we put 1 right there. We look at 2, how many times does 2 show up in the data set? So we do, so that is 2. And where's the other 2? Okay, so 2 shows up 3 times, right? So we have that there. So you cross out and you do that. Is that okay? Now, in some respect, you may have also come across how to use the tally system. The tally is the same as the frequency, all right, where you do 1, 2, 3, 4, and then the 5th time you cross this out, okay? So that also can be used, okay? But this helps you to identify which has already been put on the frequency table. Okay, so we organize that and we put that there. So on this table, you see number of customers and the proportion. So the proportion refers to the fraction, right? So the total gives you what, 50, and the proportion is how many times one shows up over the total, and that gives you the percentage, right? So here, that creates a table. So that's how we did the proportions, okay? So for each number of times divided by the total number of customers, and that gave us proportions. Isn't this beautiful? Now it looks more organized, right? Now let's use this data set to run some analysis on this table. And this will lead us into the whole conversation about probabilities. Now, what is the mode value for the minutes customers waited? You remember the mode? What is the mode? The mode is the number with the highest frequency. So what is the mode value customers waited? Isn't that 5 minutes? Because the mode is what, 12, and that was for 5 minutes. Is that okay? Now, what is the longest someone from this study waited? What is the longest someone from this study waited? The longest someone from this study waited is what? 9 minutes, because you know that the longest somebody waited in this minute. Now, this does not necessarily mean that nobody has to wait that long, right? Just not from this particular group. Now, how many people from this data waited at least? The name is, I'm saying at least 6 minutes. The least time is what? 6 minutes. At least 6 minutes. What would that be? At least 6 minutes. So look at it. So the least is 6. So what do? So now you have to what? You have to put these together, and this is the least. So you sum all these up, and that is the least. Okay. So, and I'm going to give you a catalog of information on what to do, what to include when it says least, okay, and all those kind of statements. I will give you a catalog of information on how to deal with those. Okay, those can be a little confusing. Now, how many people from this data didn't have to wait more than 3 minutes? So didn't have to wait more than 3 minutes. They didn't have to wait more than 3 minutes. So you put these together, and that gives you the number of customers that did not have to wait more than 3 minutes. Now, what does the total of the frequencies represent? The total of the frequencies represent the number of people who participated in the survey, right? And what is the total of the proportions? If you put all the proportions together, what should that be? That should be the last column, all right? And that gives you what? 100%. So if you put all these proportions together, the total is right here. And that is what? 100%. Is that okay? Sounds good. Gucci, Gucci. All right. So here is the information I promised to give you. So this is a bonus slide. And do I include the endpoint value or not? So we want to look at interpreting the question correctly. Now, what values would you include to find the probabilities for these statements? 4 or less. 4 or less, that means you have to include 4, right? Less than 4 does not include 4. 4 or more means you include 4, right? More than 4, that means you do not. And at least 4 actually means 4 or more. Is that okay? So that is how you navigate this kind of information. So pay close attention to some of these words. And we are going to use these words a lot in our conversation about probabilities. Gucci, Gucci. All right. Are you ready to move to the next? All right. Sweet. Now, we come back to this data set and do further analysis using some of these statements we just looked at. What proportion of customers wait 5 minutes? So we are talking about proportion. So you have to look at the proportions column, right? What proportion of customers wait 5 minutes? Okay, that is 12 out of what? 50, which is what? 24%. So this is it, the proportion of customers that wait 12 minutes, and that is 24%. Now, if we were to select a customer at random, what is the probability they wait 5 minute. The probability that the customers wait 5 minutes, 12 out of 50, and that is what, 24%. Okay? Okay, gradually we are getting into the conversation about probabilities. Very fun conversation. Now, if you select one of the customers as random, what is the probability the customer waited 1 or 2 minutes? So 1 or 2 minutes, the proportion. We are still looking at proportion. Okay, so you put these proportions together, and this is a very good thing to note. Or in probability means you add, right? So you put these two together, and that gives you that. Now, if you were to select a customer at random, what is the probability the customer waited less than 10 minutes? Less than 10 minutes. That's already a given, right? So that's 100%. All of the customers waited less than 10 minutes. So you have to put all these proportions together, okay, including these guys. And then that gives you what? 100%, the total. Now, if you select one of the customers at random, what is the probability the customer waited more than 10 minutes? Did anybody wait more than 10 minutes? Nope. So that is 0%. Is that okay? Nobody in this survey waited more than 10 minutes. Now, what is the probability the customer waited at least 7 minutes? The least time is 7. Least 7 minutes. And that is what? 22%. So basically, you put these together. Okay. And that is 22%. Or you could have just done this over that, over 50. All right. And that will give you the answer. Is that correct? Nice. All right. So now we want to construct a histogram of frequencies of the customer's waiting time. Okay, using the data we just looked at. And that will give us a nice symmetrical or normal guy. Isn't that cool? That's super cool, right? Nice. So symmetric, most people wait about 5 minutes with a few at the extremes. All right, now if this graph above had the percentages labeled, okay, on the y-axis, would the graph be the same or different? The shape would be the same. The percents are determined out of the whole of 50 customers. All right, nice, nice. So here, we know we're going to look at the whole game that led to the probability game. Now, if you flip a fair coin, so if you have a quarter, just take it. Now, what is the probability of landing a head? So if you look at the quarter, usually for coins, there's a side that has a head. So we call that the head, okay? And then the side that does not have the head, that has whatever is called the tail. Now, what is the probability of landing a head? Okay, that a head will show up. So it's either a head or a tail. So the probability that you get a head, which is P of H of a head, is what? 1 out of what? 2. Because there are 2 chances. You either get a head or a tail. So 1 out of that, and that is what? 0.5. And that's what we're saying, 1/2. So there are only 2 ways the coin can land, either head or tail. You are looking at that. Now, we define probability right now. So probability is a chance that a specific event may occur, and is commonly expressed as a ratio. Is that okay? So the probability that you show up in class, if you say that probability is 50%, that means you're not too sure. It's 50-50, right? If you say the probability is 20%, that's you have a low chance of showing up in class, okay? So that is how we're gonna look at probability. Now here, what is the probability of rolling a 5? So if you're talking about a die, okay, You all know what a die is, don't you? Right. So we look at what we call the sample space, or the possible outcomes. So if I have a die, or the sample space for a die, I can either get 1, 2, 3, 5, and 6. So the probability of landing ahead of a 5, so P of 5 is what? 1 out of 6. 1, 2, 3, 4, 5, 6, right? And that is the probability right there. Now, so this is what we look at, but I'm going to use this same die analogy to explain the whole rules, the rules of probability. Okay, we will look at the rules of probability, and we will look at that in detail. So determine the following. Okay, we want to determine the following and see what we can do. And then we come to the rules of probability. So probability of rolling a number less than 5. Okay, that is what? 4 out of 6, which is 2 out of 3 as a reduced fraction, and as a percentage, 66.7. 2 or a 3. Okay, and the probability of rolling a 7 is 0, right? And the probability of rolling a number less than 9, that's what? 100%. And here, this is why I take a break and take you through this the cardinal rules of probability, right? So I'm going to share a wide screen, and I will use this to explain the rules of probability to you. Okay, so I will use the die approach. So the sample space, or the number of possible outcomes if you cast a die. So the number of possible outcomes, which I call the sample space. Oh, blue, this is cool. All right, so the sample space is 1, 2, 3, 4, 5, 6. Now the probability of landing ahead a 1 is what? 1 out of 6. The probability of landing a 2 is 1 out of 6. Okay, that is why we call it, in probability, we call it a fair die. If the die is fair, it's not being skewed such that, you know, you get whatever number you expect. Okay, we call it a fair die. And this is also 1 out of 6. So you realize that all these numbers have equal chances. They have an equal chance of occurring. Is that okay? Now, let's put these together. The probability of landing ahead, the probability of landing is a 1, a 2, a 3, a 4, a 5, and the probability of landing is 6. If you put all these together, each of them is 1 out of 6, 1 out of 6, and 1 out of 6. So 1, 2, 3, 4, 5, 6. What do you have? If you sum these, what do you have? You have 6 out of 6, which is what? 1. Okay? And that should tell you that, and that is, if you look at your book, pages 209, okay, it tells you this rule. It simplifies this rule appropriately, okay? So this simplifies the 3 rules of probability. So probability of an event, okay, is the number of ways that event can occur over the total number of possible outcomes. So that is what we use to find each of these. Number 2, any probability always must be between 0 and 1. So probability can never be above 1. So probability must always be between, so the probability that an event will occur will always be between 0 and 1. So if you are finding a probability and you find a probability and it gives you 20, you have to rethink it, because that means there is something wrong. So probability is always between 0 and 1, okay? So 1 means you are very certain. So if you say 1 is equivalent to what? 100%. That means you are very certain, or you are very certain of the outcome of that particular event. So this is 100%. Is that okay? Nice. Now, the third rule says that the sum of the probabilities of all unique possibilities is 1. So if you do your probabilities right, the sum of the individual probabilities must be equal to 1. And that is what I demonstrated to you right here. Okay. So this is all probability is about. Okay. And you can always check your results to know whether you're right or you are wrong. Is that okay? So basically, this is what here we end this conversation with the rules of probability, and then I'll meet you in the next video to talk about probability operations, where we look at the not and or condition, and possibly we also be looking at the conditional probabilities as well. Okay, so thanks for your time, and I will see you in the next video. All right, so bye-bye.